Hi everyone. Hello, hello. Can see you all dropping in. Welcome to our 5th episode of Home Delivery Click and Connect. We're nearly at the end of our series, so we've got two more left, which is very exciting. Creative City Hobsons Bay created Home Delivery Click and Connect as a new online program that delivers creative content directly to you on your Thursday lunchtime. Each week we've been chatting with artists and creatives and getting some live performances, all for you to enjoy from the comfort of your home. So welcome to David Murphy, if you're here to join me, David. Thank you. Hello, lovely to see you. Before we get started and kick off, I would like to acknowledge the traditional owners of the lands in which we meet today, the lands of the Kulin Nation, and I pay my respects to elders past, present, and emerging. We're all meeting on different lands today, but the traditional owners of this land are the original artists and educators. Hi there, I'm just going to ask you to turn off your cameras and mics for now. If you can, that would be fantastic. If you've got any comments or questions, please feel free to pop them in the chat and I'll be happy to read them out and ask David as we go along and at the end of today's session. So David, I'm going to share the keynote that you've sent through and you can just have a chat. But you're an amazingly multidisciplinary artist. You're a local, you've worked across multiple different kind of platforms and media, and you have a practice that intersects between science and visual art, which is really very rich, very diverse. So, that's a pretty succinct overview of your incredible practice, but I'm going to give it over to you to kind of expand on that.
Yeah, thanks, Matto. Thanks for asking me along. It's great to be here. And thanks also to Hobsons Bay City Council, who have been very supportive with this project, Fibonacci's Genie, and, occasions like this one. So yes, I do a lot of different things in my practice, and I often work in between science and art. I've been interested in mathematics a lot and chemistry, as well as physics and other things. But today we're just going to speak about this project, which was really the Fibonacci's Genie, which was funded last year during lockdown. Hang on, if you go back one slide, Matto, I'll start with, this is an old work actually, but also relates in a strange way to this new work that I'm doing. This is a permanent work that it's owned by Hobsons Bay City Council called H2o Stint Map, made in 2003, I think, and it's a water molecule on top of a spire, Fibonacci spire, that's down at Skeleton Creek. But it shows my interest in the molecular world, but also in the maths with the Fibonacci numbers there expressed as that column, that spire in the middle. A more recent work is the next slide, which is called Rubisco 358. This is a sculpture that I also made last year, so it's much more recent. Also made out of stainless steel and mild steel. And it shows the relationship between DNA and the Fibonacci numbers, or the golden ratio. And this one is actually the first fold that DNA makes when it's folding itself down inside a cell, inside a nucleus, which is called a nucleosome. And this one's coated with a particular enzyme, or part of a particular enzyme, I should say. And the next slide shows another view of it, which sort of gives you a bit more of an idea of, or shows the sort of the DNA structure a bit more. So those little sort of circular things are spinning around the outside, they're the code. So there's 4 different shapes, or 2 different shapes in 2 different metals that spell out the code, the beginning of the code of Rubisco. Rubisco being the most common piece of DNA on the planet, which is responsible for splitting carbon dioxide and fixing carbon into the plant world. So
Amazing. Is this what you've got sitting behind you as well? Is this a
that is a section of that. It's a smaller work, but related, very much related to that. So
beautiful?
that's yeah. You can see that there being. Oh,
And
um,
do
yeah,
you make those models before you go into making the largest? Wow.
yeah. Uh, Yeah, look, there's a lot goes into a work like this. Trying to work out how to build it is a big part of the challenge. So I tend to start with the easy bits and then go from there. So that is just a small section that I made in preparation for building the larger one
Yeah.
that you see the photos of.
Amazing. And
Um,
I love that you told us what Rubisco is, because I would have no idea. And I'm sure you might be explaining this later, but what is Fibonacci?
The Fibonacci series is a series of numbers that is attributed to a mathematician from Pisa in Italy around the 10th century. He posed a problem about a thought experiment about how rabbits multiply. And the answer to that question was a series of numbers, which is now called the Fibonacci numbers. And you find those numbers in things like pineapples, pine cones, sunflower seeds. And it's a series of numbers that very much relates to the natural world and also to the golden ratio. There's a lot in it, but the series of numbers is 1 + 1 = 2, 1 + 2 = 3, 2 + 3 is 5, 3 + 5 8, 13, 21, 34, 55, and it keeps going up. And the bigger those numbers get, the closer neighbouring numbers, like so 34 and 55, for instance, when you turn that into a fraction, that will approximate the golden ratio, which is the sort of also quite an amazing number in many ways. So it's
That
like
is
the whole number.
That's incredible. I mean, as from someone that is mathematically pretty challenged, I'm really interested how you take that concept and move it into something like a sculpture or a visual artwork.
Well, when I found out that the DNA, the DNA molecule exhibits that relationship and that ratio in a number of different ways, I was really fascinated. I've always been fascinated with the golden ratio and the Fibonacci numbers. And so when I found out that DNA exhibits that ratio and that number, I became really interested and I started looking into it. So that's what's resulted in this latest series of works, which sort of all explore that relationship, really.
Awesome.
I think that answers your question. So this was a 3D model that I created for a related work to the last image we saw. That was to be in the Royal Botanical Gardens in Melbourne last winter. Of course, that didn't happen. And having done a lot of work on the design and preparation for that, I was then lucky enough to get one of the Art Apart grants from Hobsons City Council. Amazing. And I was able to then make a sort of a prototype version of it, really, which involves, here it is being constructed. So this is what it looked like at one point when I wasn't sure if it was even going to become what I had imagined. But surely it took, it started to take shape. The next shot shows it inflated and me trying to make sense of all these many meters of rope that I had that I was expressing. So, for instance, there's in this one, there are 5 blue ropes, there are 8 black ropes, and there are 13 red ropes. And so if you go to the next slide, you'll see how that relates to things like the Norfolk Island pine tree leaves, which exhibit us very similar. They have the same numbers. It has the same numbers in there, and you can see a number of those spirals that I used sort of shown in those. And so I then managed to if we go to the next slide, you can see this is me getting it sort of slowly working with the lights in it. So I should explain that this proposal involved 10 turns of the DNA molecule. Each turn of DNA has exactly 10 pairs or 10 base pairs in it. And so this is 100 pairs of lights. And through those lights, I was then able to work with a fantastic lighting designer, Paul Lim, to create a system that was able to then use genetic or genomic data as lighting sequences. So this is the beginning of Fibonacci lighting, the Rubisco, I should say, the Rubisco code being put through the work, Fibonacci's Genie. And the next slide shows Fibonacci's Genie exhibited down at Logan Reserve at Altona, near Altona Pier there one night last summer when we were all able to get out and about. And so I put that up. I should say also that there's a soundtrack that goes with that. So we not only turned the genomic code into light and colour, but I worked with another friend of mine who's a fantastic musician and composer, Stephen Grant, who sonified or came up with a series of ways to use that genomic data to create compositions with. So there was a music component that was in sync with the lights that went through, and so there was a soundtrack that goes along with it.
Amazing.
Go to the next slide. There's another image. Now that's a still image from when we tried to exhibit the work many times last year. It kept getting put off and put off. So I was very fortunate that then Hobsons Bay came to the party with a little bit more funding to create a short film of the work so that we could, instead of exhibiting it publicly in the flesh, we were able to put up a work on YouTube that sort of shows the work. So maybe if we can, that's a 4-minute film, so maybe we'll have a quick look at that, and then that's the best way of describing Fibonacci's Genie, is if we watch that film.
Just quickly before I go to the YouTube, I'll just read out, on the blower, as mentioned, is there tension between order and chaos? And where are you on that?
There's always tension between order and chaos, yes. Entropy likes, but yeah. Yeah, it's interesting, I guess. Entropy is more like, the cosmos, and order is life. I mean, life is sort of what creates that order, or particularly this order. So interestingly, the number, the golden ratio is a number that I described before that relates to the Fibonacci numbers. Now, there's a mathematical proof that proves that the golden ratio is the most irrational number that in mathematics. So an irrational number is a number where, like pi, for instance, where there's lots of points such and such and such, so it can never be expressed as a fraction, and you'll have this never-ending stream of digital numbers, numbers after that. There is actually a mathematical proof that proves that the golden ratio is the most irrational of all the irrational numbers. So I find it really beautiful that the most irrational number known to mathematics is a number that is intrinsically linked with life. So, life does seem pretty irrational at times. And so that's been an interesting sort of thing.
I love that too. I really love that as well. Tanya's saying, loves hearing the thinking behind your work, David. Really clever. I would agree. I think this is definitely out of my field of understanding. But I really love the pretty colours of the work.
Well, thanks for noticing, Matto, because I certainly don't want to make work that is only kind of to be looked at by mathematicians or scientists. And so very much a part of what I always try to do is to make work that is accessible on many levels. And so lots of different people can actually look at it and get something out of it one way or the other.
Perfect. I love that too. I think multiple entry points allow for better quality work for sure. And John is just saying, Fibonacci's Genie, what's the genie and bottle idea? Is there a metaphor? Is that a metaphor for life?
Yes, thank you, John, for noticing. It is a metaphor, you know. Obviously, a lot of people know what a genie, or have an idea of a genie, and there's no actual relationship and what between the words gene and genie, but I thought that was a very interesting sort of it brings up an interesting idea, the fact that genes create life and the genie was able to, you know, grant wishes. So there is a sort of there's an interesting relationship there.
And the use of recycled bottles in the work too, I think.
Sorry?
The use of recycled bottles in the work,
Yeah,
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 is a really beautiful connection to that. And you're really a big recycling advocate, aren't you?
absolutely, absolutely, yes.
Okay, cool. I'm going to quickly share this YouTube video. It goes for 4 minutes. We're just going to have a bit of a watch of this, and then we can chat more after this one's finished. Wow, absolutely mesmerizing. Really beautiful. I will recommend that everyone, if you want a better quality video and sound, we are on Zoom. So please go onto YouTube and you can watch that yourself if you want to hear the really haunting and surreal soundtrack that goes along with that work.
Yeah, yeah, that's Stephen Graham. Fantastic.
Amazing. And I love the aerial shot with it placed amongst kind of the natural grasses and reeds is so alien. Really,
Yeah,
really, yeah,
yeah, yeah.
disturbing. I love it.
Yeah, well, that's filmed just down at Corroy Creek in Hobsons Bay.
Amazing. I'm
Yeah,
up in Albion near the start of Corroit Creek, actually.
yeah, right.
Yeah.
Great, fantastic.
Brilliant. I'm just going to read out. Caroline's just said so cool, and yeah, I would agree. I think it in situ, this work, this sculptural work in situ, because it's using those very garish RGB or rainbow LEDs. It's so alien and really cool, and stands out from the natural landscape really well. Beautiful. Does anyone have any further questions or comments? Mina's asked, has any artists influenced or inspired your work? I mean, it sounds like your work is directly inspired heavily from maths and science, but yeah, what other visual artists would you say inspire you?
Oh, look, there are many. I think these works are particularly sort of stand alone a little bit. So they're not necessarily following after anyone in particular. And yes, the maths and the science is really what drives this work along. But yeah, in general, yes, I would. I'm sorry, I'd have to just say they're too numerous to mention at the moment. But
Yeah.
yeah, I do. I enjoy sort of sifting through influences and letting different things sort of take my lead. Yeah, what can I say?
Yeah, that's all right. I think a lot of artists do the same. We have multiple kind of interests and entry points, so it's really exciting. My practice is not based in maths or science at all. That's definitely something I struggle with. So hearing about those really rich and in-depth scientific practices that you're bringing in, giving meaning to existence through numbers and maths and DNA sequences, I think is incredible.
Oh,
I
thank
did
you.
mention before you're a big advocate for recycling. I do want to jump back to that quickly. That wasn't just a random statement. Your house, am I incorrect in saying it's made from over 70% of recycled materials?
Well, yes. I mean, it's a very hard number to come up with, but yes, I built a house, and there is a lot of recycled material in it. Exactly how you measure that, I don't know. So the guess is, yeah, somewhere between 50 and 100%. Well, it's not 100%, but yeah, somewhere between 60 and 80%, I would say. But yeah, there's a lot of recycled material in the house.
Amazing. And is that something that you bring into, obviously with Fibonacci's Genie, we've got those milk bottles, but is that something that you consider when building or making work?
I'm absolutely always thinking about keeping my carbon footprint as low as possible. I think it probably enters, and I have made a lot of work out of recycled material over the years, but it probably influences my day-to-day life more than my art practice, especially at the moment where I'm sort of interested in these sort of molecular things. I mean, it sort of, yeah, I mean, it relates. The one of the statements in there was that there's thinner than light. The DNA is thinner than light, and so to me that's a really fascinating thing, that the width of a DNA molecule is thinner than a wavelength of light. So it's sort of it's technically unseeable with light. The only way we know the shape of DNA is through X-ray crystallography. So you sort of bombard it with electrons and look at the shadow and the shadows that it makes, and then you can sort of determine what shape it is. And so with this work, it's really interesting to me that these are kind of a real world, they're real objects. They're molecules. We know they exist. We know a lot about them, but we can never see them. And so even though you can represent a molecule really faithfully, in a sense, it's always going to be abstracted to some degree or another. So that's probably getting more back to the influences than the recycling. But
No, that's great. That's amazing. Yeah, it's almost like a leap of faith in a sense as well. If we can't directly see them, we're just kind of seeing their shadows or their influence.
Yeah, yes, it is there is a leap, and that's, I guess, partly that a lot of that's about science. We have to have faith in science that what they're telling us is true. So yeah,
And more so than ever now.
that's right.
Yeah.
Yeah.
John's saying, what is your reflection on the work since the video? Did you learn something about the relationship with the sculpture and the site after you'd finished the project? I think that's an excellent question.
That is a great question, John. Yet another one. Thank you. Did I work more? Yeah, I learned. I mean, it was so fantastic to take it out of the studio and see it in nature. That was one of the most fantastic things about filming that video, because essentially DNA is nature. Like there is no life without DNA. We don't know of any life form at all that doesn't have DNA in it. And all DNA is exactly the same shape. It all operates in the same way. And so to take that sort of, I often think of them as portraits of DNA, because they're not a photograph. They're not a sculpture. It's like it's a portrait. It's a sort of an approximation. And so to see that portrait of DNA in nature and in such a beautiful place that's so close to where I live was a really fantastic moment. And yeah, I think there were other realizations that came from filming the work too, which I probably won't come out until future works, but I've certainly, since filming that, come up with ideas to combine those two works, like this work here and the work with the lights on it. So I'm very interested in creating a work that is made, that is not an inflatable work like that one, which is sort of a more for events and lightweight work, but something that's more a permanent work, but still has the ability to be able to be programmed with light. Beautiful. With genomic data. I'm thinking that at the moment a lot about genomic data. We have all this incredible wealth of information about life and different forms of life, and it all gets distilled down to these 4 letters, A, T, C, and G. So I'm thinking about all of that data and trying to find ways of using that data as a sort of an art medium, I guess, and trying to sort of play with that data as a medium in a sense.
Amazing. I love that. I've also got a few more questions. On the blower said, did maths already exist or did people invent it? Please expand. Now, you've got 1 minute, David, to answer the meaning of the universe here.
Yeah, the answer to that is yes, it did exist.
There you go, on the blower. Done. Definitive. And finally, John again has said, have you thought about using living cells or tissue? Pretty
no,
crazy.
John, but I'd love to talk about that with you further.
I mean, so I think there was a show at Science Gallery not long ago where they had living Petri dishes full of cells.
Yeah, it's a little bit hard. What really fascinates me is this ratio, and the Fibonacci numbers. But you couldn't really work with DNA to work with that, but you could certainly work. I often take photos of pine cones and pineapples, or like things that exhibit the Fibonacci numbers, and so that potentially could become a way of creating work that was from visible, from nature that sort of exists at our scale, rather than the nanoscale, which is kind of in another realm, really.
Yeah, beautiful. Well, it's 12:30. I mean, my mind is blown and expanded. I don't know about everyone else, but I definitely need to go and think more about science and maths and do some more reading. I'm just going to say thank you so much for joining us today, and thank you so much, David, for sharing this project. It's pretty incredible. It's really lovely to see the different outcomes as well. And I will recommend that you all join us back here again next Thursday for our final home delivery Click and Connect with Jeff Ricardo and Heidi Weatherold. They're going to be discussing their collaborative project Come Fly With Me. So next Thursday at midday for our final Click and Connect. Thanks so much, David.
Thank you, Matto.
I can't wait to see.
And thanks to the fantastic audience and all those great questions. It's got me all thinking about new work too. So
brilliant! It's a win-win outcome for everyone then. Fantastic. Enjoy the rest of your day and get some sunshine.
Thank you. Bye.
Bye all.
Well done, Murphy.